Today we will discuss prime factorization.
Having that crazy face. All right, ladies and gents, let's talk about prime factorization. Before we get started, we need to understand what the word prime means. Prime means that a number can only be multiplied by 1 and itself. So right here is a list of prime numbers that are less than 20. 2, 3, 5, 7, 11, 13, 17, and 19. What that means is when we take a look at the factors of these numbers, they can be multiplied by themselves and 1. When we take 2, that would equal 2 times 1. There's no other combination of two numbers that could be multiplied to get these. All right? This is going to be very beneficial to understanding prime factorization. Now, you may be wondering why 1 is not on this list. 1 is kind of tricky. It's neither prime nor composite. Composite, what's that mean? It's a set change, boys and girls. New attire, just to talk about composite numbers. So, prime numbers, the factors are only itself and 1. So if we were to say, what's the factor pair of 7? Well, the factors of 7 are only 7 times 1. That's a 1. That's the only combination that I can multiply to get 7. There's no other possibilities. Now, composite numbers, on the other hand, let's say, for example, 12. When we look at 12, it has a bunch of different combinations of numbers that can be multiplied to get the product of 12. So when we look at 1 times 12, that's one combination. We have a factor pair of 1 and 12 multiplied together equals 12. We also have 2 times 6. So right here we have two factor pairs. Here's one and here's another one. And then lastly, the combination that can be multiplied together to equal 12 would be 3 times 4. This would make 12 a composite number. So we have prime versus composite. With prime factorization, what that means is we're taking a composite number and we are writing it using all of the factors that are prime. So when we get to the bottom of our factor tree here, looking at the example using 60, all of the numbers on bottom of this tree should be prime. And I think it'll make a little bit more sense once we look at it at an example. To get the prime factorization, boys and girls, we're going to do a factor tree. That's what we call this. So if we look at 60, we want to start off with any two numbers that multiply for 60. So the first example I'm going to use is 4 times 15. Now, when I look at 4 and I look at 15, I know that both of those numbers are still composite. They're not prime yet. So I can break those down even more. And 4, I could use the factors of 2 times 2. And 15, I would use 3 times 5. When I get to a point where the numbers are prime, I like to circle them. I just think it's a good strategy. So 2 is prime, right? Factors of 2 are only 2 times 1. That's the only combination. This 2 is prime, 3 is prime, and 5 is prime. So I could write this 2 to the second power times 3 times 5. This is the prime factorization of 60. Now the question that you may ask next is, well, what if I didn't want to start with 4 times 15? Prime factorization, using the tree, you'll always get the same factorization. So when we take a look at 60, another possible combination is 2 times 30. Now, remember what I said just a second ago. If it's prime, circle it. So 2 is prime. All right, I'm going to hold that there. 30, 2 times 15. 2 is prime, I'm going to circle it. And then 15 is 3 times 5. Both of those are prime. Now, look what I have. 2 times 2, which is the same over here, times 3 times 5, which would be written 2 times 2 is 2 to the second power. Think back to the exponents, the video that you watched earlier. 2 to the second power times 3 times 5. All right? Ladies and gents, if this is confusing, you can check out page 26 and 27 of your textbook. Good luck on the questions that are coming up.